Greetings for the day. I am Shweta Rajoria, Assistant Professor at SIT Bhopal in EC Department. Welcome to the series of lecture on wireless network. Today is our fourth lecture. In the today's lecture, we are going to see the spread spectrum. The spread spectrum is actually a modulation technique in which a narrowband signal is modulated over the signal that is having a very large bandwidth. The spread spectrum technique employs a transmission of bandwidth that is several order magnitude greater than the minimum bandwidth required of the signal. Now, we consider if we have a signal having bandwidth B, then we will transmit our signal on the bandwidth BSS. The bandwidth BSS is very high than the bandwidth B. In the spread spectrum technique, all the signal that we need to transmit occupy the same large bandwidth, that is BSS, and these are differentiated by code. The signal are spreaded with different code, so they can be separated at the receiver side. Now, the another important feature of spread spectrum technique is that it can be spreaded in the time domain as well as in the frequency domain. The prime feature of the spread spectrum technique is that it provides a very high security against the jamming and interception. This is the baseline concept of spread spectrum technique. From the figure, we can see that this is the signal that we need to transmit, and it have the bandwidth B that is very small. Now what we do that we will superimpose this bandwidth with the spreading code. This spreading code has very large bandwidth. Then the required signal will be the signal that has very large bandwidth, that is BSS. Mostly this BSS bandwidth is equal to the bandwidth of your spreading code. This is the generalized spread spectrum diagram. There are a little bit change according to the particular spread spectrum modulation technique, but the baseline concept remains same. From the figure, we can see that this is your transmitter side and this is your receiver side. This is your channel. At the transmitter side, what we actually do, first, this is your input data. It can be of any type. Then you channel encoder encode the data into proper format that can be transmitted. Now the output of your channel encoder is the signal that is the narrowband signal. Now what we do in the spread spectrum technique, we modulate that narrowband signal by with the signal that have a very large bandwidth, this spreading code. And this spreading code is generated by the pseudo noise generator. What is pseudo noise code? We will see in the later slide. Now after that, the output of the modulator is the wideband signal. Now this wideband signal is transmitted through the channel. At the receiver side, first we despread that spreaded signal, that your wideband signal is spreaded either in the bandwidth, either in the frequency or code that we will see in the later slides. First, this demodulator, what actually do, it despreaded your signal, and at this side you will get your signal that you are transmitting. After that, the channel decoder will decode your signal in the original form. This receiver side operations are completely reversed to your transmitted side operation. Now, all the things that I mentioned in figure are written here. Input fed to the channel encoder produces channel encoder produces a narrow bandwidth analog signal around the central frequency. The signal is modulated using the sequence of bit spreading code typically generated by pseudo noise generator. This increases the bandwidth of your transmitted signal, that is your received signal is the spreaded signal. The receiver uses the same sequence to demodulate your signal, and at the end you will get your original signal at the demodulator site. Now, before moving forward, first we will see what are actually the advantage of your spread spectrum technique. It provides the immunity from various noise and multipart distortion. And it all, as I mentioned, it provides the high security. It includes the jamming. It can hide or encrypt your signal. That only receiver can, who have the spreading code, can retrieve the signal. Several users can share the same high bandwidth with a little interference. That is another important benefit. If we are using the large user, there is a very less chance of interference as we are providing orthogonal codes. And this technique is used in cellular phone, CDMA. Now first we will see what is pseudo noise sequence. PN sequence, named as pseudo noise sequence or pseudo noise code, is a binary sequence that appears random in nature, but it can be reproduced in the deterministic manner at the receiver side. It is generated by the algorithm having some initial seed. There are various algorithms to generate the pseudo noise sequence. These generated sequences are not actually random, but if we have a good algorithm to generate them, then they pass all the tests of randomness. And we need to know these algorithms to predict the sequence at the receiver side. Now we will see the different type of spread spectrum techniques. There are broadly two type of spread spectrum techniques. One is the frequency hopping, another is the direct sequence. In frequency hopping, signal broadcast over seemingly random series of frequency in which the signal is superimposed on the different set of frequencies. And in the direct sequence, each bit is multiplied by a series of bit, or we can say multiple bit. And these multiple bit, the series of bit is known as chipping code. In my previous lecture, CDMA, I have given you the overview regarding the spread, direct sequence spread spectrum technique. In the today's lecture, we will mainly focus on frequency hopping spread spectrum and see a little bit about the direct sequence spread spectrum technique. Let's start with the frequency hopping. In the frequency hopping technique, signal broadcast over seemingly random series of frequency. The receiver hops between the frequency in the synchronized manner with the transmitter. In the frequency hopping, eavesdropper hear unintelligibly. Jamming on one frequency affect only the few bits. Means there is very less probability of your signal to be getting error. This is the basic operation. I will come to this slide laterly. First, we will see the transmitter and the receiver block diagram of the frequency hopping spread spectrum technique. This is your basic transmitter diagram. From the figure, we can see that you have your binary data that you need to the transmit. First, you do the modulation, that is FSK, frequency shift key, BPSK, QPSK, any modulation technique from which you need to transmit your data. Now, this modulated signal is frequency hopping spreaded. For that, what we will do, we will apply the input output of your PN sequence generator to the frequency synthesizer, due to which this frequency synthesizer will produce the random set of frequencies. Now, this random set of frequencies will help to modulate your input signal, and this output signal here, the output signal is spread spectred in term of your frequency hopping, and this is passed through the band pass filter. After that, this spread spectred signal is transmitted. The reverse operations are being obtained at the receiver side. In the receiver side, first this spread spectrum signal is despreaded by using the similar reverse process. This pseudo noise code will be given to the frequency synthesizer. This frequency synthesizer will produce a set of frequencies. Then these are multiplied by your received signal. Then you will get your despreaded signal here. After that, this despreaded signal is passes through your band pass filter and it is demodulated as per the scheme that you have applied at the transmitter side, and here you will get your binary data. Now we will see how actually this performs. For example, after modulation, either applying any QPSK, BPSK, any modulation scheme, you will get this data, K bit pattern, and you need to transmit this data using the spread spectrum technique. Now, what actually do? For example, here 101 is mapped to your 700. 111 is mapped to 900. Each bit is provided a frequency, and this frequency allocation is random, and this table is also shared with your receiver side. And then, for example, you need to transmit 000, then you will choose the frequency 200. You need to transmit 110, then you will choose the frequency 800. After that, all this transmitted data is clubbed and transmitted through a common channel, and the bandwidth of that signal is very large. So we say your input signal is spread spectrum, that all the bits are combinedly transmitted through spread spectrum technique, but at the different frequencies. Now, first we will see that. Now, what actually happening? Yes, is your complete frequency that you are provided for complete time, but in the spread spectrum, you are not using your complete frequency band, you are using a chunk of frequency band. So this is also bandwidth efficient if there are a large number of users. Now, the frequency hopping technique is divided into two categories. One is the slow frequency hopping, another is the fast frequency hopping. In the slow frequency hopping technique, the coherent bandwidth of your channel must be greater than the coherent bandwidth of your signal. Whereas in the fast frequency hopping, the coherent bandwidth of your channel should be smaller than the coherent bandwidth of your signal. Now, what are the performance considerations? As we know that the frequency hopping technique provides improvement or resistance against jamming. Now we come to the direct sequence spread spectrum. In this technique, as I mentioned, each bit is represented by multiple bits using the spreading code, and this spreading code is known as the chip code. Spreading code spreads the signal across the wider frequency band in proportional to the bits. For example, we are mapping or we are spreading our 1-bit code to the 10-bit code. Then 1 bit is your input signal and 10-bit is your spreading code. Then output code will be 10-bit code. The performance is similar to your frequency hopping. This is the basic block diagram of the transmitter of direct sequence. For example, this is your original signal. It is a 1-bit code. It is a chip generator. It generates a code of 10 bits at 1 clock. Now we modulate this 1-bit code, or we can say we overlap this 1-bit code to the 10-bit code. After that, your spread signal having the code length of 10 bits. The same procedure is mentioned here. Combine the input signal with the spreaded code using XOR. The input 1 bit inverts the spreading code bit. The input 0 bit doesn't alter the spreading code bit. The data rate is equal to your spreading code. We can adopt another process also to spread. This is one of the method that I have encountered. And we have used the similar method to map this original signal with your spreading code. After XORing these two, we get this result as an output. Now what actually happened by the direct sequence? Here you have your input signal, that is 1-bit code having very small bandwidth. This is multiplied or XORed by a very large signal having the bandwidth very large, and after that at the output you will get your spreaded code that we are going to transmit. This is all about spread spectrum technique. CDMA also use the spread spectrum technique. In the previous we have seen that CDMA by considering the direct sequence spread spectrum. In your CDMA1 technology that is used in 2G, we have considered the direct sequence spread spectrum technique. This is all about your spread spectrum. In today's lecture, we have seen the two important technology, GSM and CDMA, that is used in the 2G standard. From the next lecture onwards, we will see the UTMS technology and all the technologies step by step that are used in the 3G and 4G. The CDMA is the one of the important technology of 2G standard having the CDMA phones. Thank you.